NISAR satellite. NISAR here stands for NASA-ISRO Synthetic Aperture Radar. It is an Earth observatory satellite jointly launched by ISRO and NASA. And what this Earth observatory satellite will do? It will observe the Earth and the atmosphere of the Earth for its climate. So, in a nutshell, it is for environment conservation, climate change and all. It was successfully launched on 30th July 2025 at 5:40 p.m. IST aboard India's Geosynchronous Satellite Launch Vehicle GSLV from second launch pad of the Satish Dhawan Space Centre in Sriharikota, that is in India. This joint mission between NASA and ISRO marks a landmark achievement in international space cooperation for Earth observation. Now, on one hand, NASA and ISRO are launching such missions, and on the other hand, Donald Trump is posing challenges for India, and these challenges we will be covering in next week's class, don't worry. About NISAR mission, full form NASA-ISRO Synthetic Aperture Radar. Collaboration, a joint mission between National Aeronautics and Space Administration of the US and Indian Space Research Organization. It represents the first major Earth observation satellite co-developed by the two agencies. It is launched by ISRO's GSLV F-16 rocket. GSLV means Geosynchronous Launch Vehicle, and this is also notable as it marks the first time a GSLV has placed a satellite into a sun-synchronous polar orbit. Now, sun-synchronous polar orbit, it is a polar orbit. Polar orbits are like this, where the satellite is revolving in this orbit. But what does sun-synchronous mean? Sun-synchronous means that the satellite passes through a particular place on Earth. If we view the satellite, so that satellite passes through that particular place every day on a particular time. It is in sync with the sun's position because time is linked to the sun's position. That is a sun-synchronous orbit. Okay. So, for the first time, GSLV, which is known for launching satellites in the geostationary orbit. Geostationary orbits are 36,000 kilometers from Earth. So, from here, satellite launching is done by GSLV, but for the first time, GSLV has launched the satellite in this orbit, sun-synchronous polar orbit. The GSLV F-16 injected the 2392 kg NISAR satellite into a 743 km sun-synchronous orbit. 743 kilometers means this distance is 743 kilometers from the Earth. It allows the satellite to always view Earth under consistent lighting conditions, crucial for accurate data comparison over time. And the life of this mission is 5 years. Unique features: the dual frequency synthetic aperture radar. Two frequencies are there of this radar, and one is the L band radar. This is the frequency wavelength of 24 centimeter. NASA has provided it. It is adept at penetrating dense vegetations and monitoring soil moisture, forest biomass, and the motion of land and ice surfaces. And all these are related to climate change, environment conservation and all. The second is the S-band radar. This has been provided by ISRO. Wavelength of 9 centimeter. Wavelength is the distance between two peaks is the wavelength. The wavelength of L-band radar is 24 centimeter, means this is wide, and wavelength of S-band radar is 9 centimeter. It is optimized for high resolution imaging of agricultural land, urban infrastructure and coastal regions. You don't need to penetrate in such kind of scenarios, but here you need to penetrate. Both radar systems utilize NASA's 12-meter unfurlable mesh reflector antenna, integrated with ISRO's modified 13K satellite bus. Now, the sweep SAR technology. NISAR uses this technology for first time in space. This advanced radar technique allows the satellite to achieve a wide swath of 242 kilometers. Means at one point of time, these radiations which will be released by S-band and L-band radars will cover 242 kilometers of diameter, area covered on the ground, while maintaining high spatial resolution. Sweep SAR works by having the radar signal feed sweep Its beam across the antennas reflect as it receives echoes, effectively expanding the area the radar can listen to and process. The applications and data collection. The satellite will scan the entire globe and provide all weather day and night data at 12-day intervals. And in emergency situations like natural disasters, data can be available within hours. And NISAR can detect even small changes in Earth's surface down to fractions of an inch. Centimeter level precision is going to be there. Wide range of applications of NISAR. Climate change monitoring. This is the first and primary application of it. It will provide vital inputs to climate models. Natural disaster management, early detection and monitoring of ground deformation from earthquakes, volcanic activities, landslides and tsunamis, and this will aid in disaster preparedness and response. Ecosystem and biodiversity, mapping land ecosystems, studying forest dynamics and wetland changes. Agriculture and resource management, monitoring crop growth, soil moisture changes, land use mapping and surface water resources. Oceanic regions, observing coastal changes, sea ice classification and all. And urban development, monitoring land subsidence in megacities and assessing infrastructure resilience over there. So all these things can be done. Now this mission, the NISAR, is in two phases. The launch phase, satellite was successfully launched by GSLV F-16 launch vehicle. This phase is over. Deployment phase in orbit, a crucial step will be the deployment of 12-meter reflector antenna, which will unfurl 9 meters away from the satellite via a complex multi-stage deployable boom. Now this process is expected to begin around the 10th day after the launch. So launch was on 10th of August, this is going to happen. And commissioning phase, in-orbit checkout, the first 90 days after launch will be dedicated to commissioning, or in-orbit checkout means we will be monitoring that how it is revolving around this sun synchronous orbit. And after that, the third phase will be over. The objective is to prepare the observatory for science operations involving initial checks and calibrations of mainframe elements, followed by payload and instrument checkout. Science operation phase, the final phase begins at the end of commissioning, means after 10 days and then plus 90 days. Then the final phase begins, and that is science operations phase, and this phase is going to continue for 5 years because this is the mission life. During this period, the science orbit will be maintained through regular maneuvers, and extensive calibration and validation activities will take place to ensure high quality data collection is there. So this can prove to be beneficial for not only India or US but the entire world, because the entire world is grappling with such kind of issues like climate change, global warming, disasters and all.